As Tina says, I'm the managing director of a company called DataStream. We operate upstairs with number 12. So we've got loads to go through today. It is going to be slightly technical and it's going to be very hands-on. And I want to speak to you a little bit about why. So why we are doing events like this and we're trying to speak to more and more businesses in the area is it takes me back to about a month ago. I was in York and I was speaking to a very straight-talking German gentleman that said, Elliot, AI to me reminds me a lot of the dot-com bubble in the late 90s, early noughties. Everybody's talking about it. It seems to be that you can't release a product or service nowadays without shoving AI somewhere in the title. You know, what's going on? You know, are you part of that sort of what he's described as the shyster movement of artificial intelligence? I said, no, absolutely not. And I think why we want to put these events on today is because there's a lot of AI events that talk about applications and they talk about rockets and robotic manufacturing and healthcare applications, which are all great applications, but they're not real tangible things that businesses like yours can do today and start implementing from tomorrow. So with that in mind, I want to go through loads of different applications. There's lots to take in. This is being recorded, so if you miss anything, if you don't get to write it down, if you have any questions, the recording will be available on YouTube and LinkedIn afterwards. So our first application is forecasting. So one of the main things that people say with my area of AI, which is machine learning specifically, is we want to be able to forecast. We want to see into the future. We often have analytics and they often tell us what has happened yesterday, what happened last month, you know, sales volume, manufacturing, things like that, looking backwards. And then we take action and then we're reacting to things that have already happened. What we want to do with machine learning, start learning from the past and predicting that forward, so then we can start taking reactive steps moving forward. So many different algorithms for predictive analysis, and essentially what they do is they take one or more inputs to predict an output. So for our first use case, I want you to imagine that you own a large consumer electronics store, something like Currys, and you're thinking, right, well, we want to optimize our warehouses, we want to optimize our staffing schedules, we want to do all of this, but we can't do that without looking forwards a little bit. So we need to know what we're going to sell on Saturday so we can get the TVs into the warehouse so that they're available in stock, so on and so forth. How many members of staff do we need? Things like that. And we can optimize the store accordingly. So if you want to start predicting sales volume, so you look forward and think, well, on next Saturday, how much am I predicted to sell? On Tuesday afternoon, how much am I predicted to sell? Well, what we can do is we can take an input or more inputs and we can predict that output. So if the output is sales volume, what can we do for the input? So an input we've taken into account here is what we call occupancy. So as you can imagine, as occupancy goes up in store, your sales volume is probably going to follow it. So that's something we call positive correlation. So the more people in store, the more they buy, sales volume goes up. Fairly standard stuff. So what we can do is we can track occupancy over the last year, 5 years, 10 years, whatever data you've got available, and we can project that forward. How does that look in reality? So it looks a little something like this, which is probably, if you've done GCSE maths, it probably looks something very similar with a line of best fit. So you've plotted your occupancy along the bottom, you've got your sales volume along the top. So that's your historical data. And as you can see, it's positively correlated, which means as occupancy increases, sales volume also increases. So then you can use that and you can get machine learning to draw that line of best fit and then project that forward. So if you say on Saturday, I'm anticipating we're going to get 100 people into store, what does that look like? Okay, we're going to sell about £12,000 worth of stuff. So, okay, well, for £12,000 worth of sales volume, we need 8 members of staff. We probably need TVs in, fridges in, things like that. You can also do this on a SKU by SKU basis, so it doesn't have to be overall sales volume for the entire store. You could say, well, run this for every single SKU that we have available so that we know how to allocate our factories and warehouses accordingly. We can optimize our delivery schedules, so on and so forth. So by using machine learning, we can actually plot our historical data and get machine learning to plot that line of best fit and project that forward. So where does the machine learning part come into it? Because again, my little brother could probably plot this line. Well, machine learning is constantly learning from this data. So as we get more and more data incoming, the machine is trying to optimize this line to reduce the amount of error. So all the gaps between what it's predicting and what the actual value was, it's trying to reduce as much as possible without us having to explicitly tell it how to achieve that result. So as we get more data in, it's constantly adjusting, constantly working it out to improve this and reduce the errors that we see. But as we all know, occupancy isn't the only thing that influences sales volume. So what we can also do is then we can create new features, new inputs that would help us predict sales volume more accurately. So occupancy alone isn't going to do that. So what can we take into account? So these are some ideas I've come up with for today. So something else, temperature, maybe, if it's warmer outside, people buy more, but to what point? If it's 30 degrees, I don't know about you, I'm probably not going to be in Curry's, I'm probably going to be at the pub or somewhere else. So to what level? If it's 0 degrees, I'm probably not going to head out and things like that. Promotion score I created, so I would argue that if there's more promotions in Curry's, more people are going to come, they're going to buy more because things are on offer. If you think of your Black Fridays, your Cyber Mondays, things like that. So promotion score is a score from 0 to 1 that I've said what percentage of SKUs in the store are on a promotion. New product launch, again, is a new feature that I've thought, well, if the new iPhone 15 Pro Max or whatever it's called is coming out this week, we can probably anticipate more sales volume as well. So that's a simple 1 is yes, 0 is no. So you probably want to identify key SKUs in your data set and saying, if these new SKUs are coming out, you can probably anticipate more sales volume. So things like the new iPhone, a new Sony television, key SKUs within. If it's a new toaster, probably not going to be a key SKU. Sales staff as well. So I've worked in retail before and I've seen queues of people waiting to be served and they eventually just leave. So, how many sales staff have we got rotated in for Saturday? If it's 1, we're probably not going to sell as many as if we had 10. But what is the cutoff? Day of the week as well. So people probably buy less Monday, Tuesday, Wednesday, probably buy more throughout the rest of the week. So Saturday, Sunday, that's probably the day you're looking at. And by taking all these 6 different input variables into account, you can then train your machine learning algorithm to ultimately predict your sales volume. So then when I've got new data and it's learned from this historical data going back years or months or whatever it is, whatever's available, you can say, right, I think this week we're going to have 100 people, it's going to be 20 degrees according to the weather, we've not got that many promotions on, there's no new product coming out, we're going to have about 5 people and it's going to be a Saturday. So taking all that into account, machine learning and AI, what is the sales volume going to be? This will be it. So essentially what you can do is then plot it on the graph. So the red line indicates ideal, so where actual and predicted equals. So essentially what the machine learning is trying to do is trying to optimize it so its predictions get as close to the red line as possible. Again, the whole beauty of AI and machine learning is I don't have to explicitly tell it how to achieve that objective. The whole idea is I've given it an objective, something to achieve, without me telling you all the rules that you need to take into consideration. Try and get these blue crosses on the red line or as close to as possible. So we're talking about reducing the error as much as we possibly can. But also, how do I know that these variables have anything to do with sales volume? How do I know the correlation between sales staff and sales volume? Is there a correlation? Should it be taking things into account? So what we can do is we can create a correlation matrix which shows you how correlated the 2 variables are. So if you can see sales volume at the bottom, you can see the strongest correlations with occupancy. So we should definitely keep that in because it says a strong positive correlation that as occupancy goes up, sales volume definitely goes up as well. Next, after that, in this data set is promotion score. So promotion score is also positively correlated as you would expect. So the more promotions we have, the more sales we sell, more items we sell. Other things are less correlated. Temperature doesn't seem to have any sort of impact in this, neither does new product launch and sales staff. It's very uncorrelated essentially. So then you can start hand-picking different variables. You might have 100 different variables that you want to consider that you think might influence sales volume. So by doing this, we can then optimize those AI algorithms to say these are the strongest correlations between these variables and the sales volume. Include these into the calculation. So I believe that's it for forecasting. Again, if you've got any more questions on terms of I want to predict this, I want to predict X, Y, Z, speak to me afterwards or ask a question at the end. This one is probably one of my favorite ones, which is ranking, which I never see a lot of, and I think it's just because the awareness isn't there. And it all goes back to before I started DataStream, I was working in Hull and was working for a company that sold printers and distributed printers. They worked with Canon, Konica Minolta, and various other manufacturers to distribute these printers business to business. And they once came up to me and said, well, you're a data enthusiast. Can you help us out? We've always believed the Pareto law that 80% of our business comes from 20% of our customers. But the issue we have is we have no idea who our 20% of our customers are in terms of who's best, who's worst. Because yeah, you can measure it on sales volume and rank it from top to bottom. But if you all have worked in businesses and ran businesses, you'll probably know that sales isn't the best indicator of how good a customer is for the business. So then I came away and started researching the problem and started thinking, well, how can we rank customers based on multiple different criteria? And so how can we take sales into account, but also financial data, operations data, customer service data? This all exists in different places, but how can we bring it all together and rank these customers based on that? So I've done a little example for you to sort of show you how it works. So this is the data set. So again, if you can't see it, I'm going to go through it. So customer ID is just so that we can relate it back to the customer, because the last thing you want is a nice, great ranking of 200 different customers and you don't know who's who. So we've kept customer ID in, but it doesn't actually have any bearing on the results. Next, we've got sales volume, our big one. So everyone is always focused on sales. We always know who's bought what. That's pretty available data. But then I went down into the belly of the beast and started speaking to operations and customer service and people that were on the phones, answering tickets, answering customer complaints and dealing with that side of things. So we started looking at support tickets. How many support tickets are customers raising? So they pay a set fee for customer support, but they can raise as many tickets as they want. They can call as often as they like, and they can have as many field engineers as call outs as they need based in the support package with a fair usage policy. But fair usage policies are great, but if you're not actually measuring it, then what's the point? Support calls as well, very similar to support tickets, so just doing simple counts of those. And then average resolution time. So, if you raise 10 tickets, but they only take 2 minutes to answer, that's not as bad as if it takes 3 hours to answer each ticket that you've raised. So we started bringing that in as well. Support consumables, so part of the support package would be toner, paper, things like cartridges, spare parts, things like that. So different customers would have different requirements, and some would hammer the consumables and buy, just order as much as they possibly can because they'd rather have too much than too little. Others would be fair and would only order it when they absolutely needed it. Cost of sales calls, again, account managers constantly going all over the country, managing accounts and things like that. And no one's measuring how much that actually costs. So, okay, great. ABC Limited spends 100 grand a year, but the account manager goes every single week and he's there all day. Well, what's the cost of that? And once you take that into account, how good is that account really once you've taken that into account? Then I went up to finance and sat with the finance people, and their data is pretty good. So I looked at missed payments, how many times, or if a customer has ever missed an invoice deadline. So, standard 30 days, have they ever gone past that? So that one for me was just a yes or a no. You could change that, and it could be how many days on average do they miss the deadline to make it a little bit fairer, because they might have missed it by 1 day, and in this it would say yes, they've missed one. And then another thing that we often did was put customers on stop all the time. You'd say pay your bill, pay your bill, pay your bill, and they never do, and then eventually you put them on stop, and then they eventually pay their bill. And this would be a constant cycle. Well, that's cost incurred for your company to start speaking to the financial controller and other people in the finance department to get these bills paid. And ultimately cost of delivery. So if it's next door, it costs a lot less. If it's free delivery, it costs less to deliver it next door than it does to go up to Inverness or down to Plymouth to do that. So by taking all that into account, we've got sales data, we've got operations data, we've got customer service data, we've got finance data. So we've got quite a broad, holistic view of data relating to a customer, and then you've got the customer ID here. So for this one, we looked at 200 different customers, and we changed the different variables to see. So what we did then is we did look kind of a managing director kind of view, where what you can do is you can weight them differently. So if you're a sales director, you probably only care about sales volume. If you're a finance director, you probably only care about finance data. So we did a managing director's view where we treated all variables equally. So as you can see here, number 1 and number 2 was customer 89 and customer 108, and the worst offenders were customer 91 and customer 182. And as you can see, based on taking everything into account, you can start to see, well, these have got a lot more sales volume, they're not raising as many tickets, the cost of sales is a lot cheaper, they haven't missed payments, these kind of things. But this is based on 200 customers. If you were Amazon, this is tens of millions of customers, things like that, and other companies as well. So that's a management director's view in terms of you take every single input in equal measure. So you don't prioritize sales over finance, you don't prioritize finance over operations, they're all equal. They're all important. So then we can weight them also differently. So what I've done here is a sales director view where I've heavily weighted sales volume. So okay, yes, they're raising a lot of support tickets, and yes, we have to go see them a lot, but I don't really care about that because they spend 100 grand a year. That's probably a sales director's view. I've heard it myself. They don't care how many account manager visits they have as long as they keep paying, which is fine. So then that changes then the ranking. So then now 141, customer ID 141 is now best because you're taking 96 grand into account more than you would do for the other input variables. And you can see it still takes the others into account, just significantly less important and less weighted than sales. And then ultimately we did a customer support view, which says, I don't really care too much about how much they're paying. Our entire customer service team are dedicated to these 3, 4, 5 accounts. We need to start taking that into account. So by ranking all of these customers, you can then start working with them. So you can say to your account managers, look, these are the worst offenders in these areas. Can you please not just target sales, but also work with them to make sure they're not missing payments, that they're not constantly hammering the calls? Do we need to introduce a training session because they've raised more support tickets this month than any of our other customers combined? So things like that, you can start being more proactive and start ranking your customers based on a holistic view instead of just saying, well, they pay the most, so they're the best customer. So things like that, but it doesn't stop just at customers. You could rank equipment, you could rank parts and things like that. But what I would encourage you not to do is rank employees, individuals. Please don't do that. I don't want to hear in 3 months' time you bring me up and say, Elliot, I took your advice. We fired Susan, Linda and Belinda from accounts because we ranked them and they came out worse. Because then you start getting into ethical issues and bias issues and things that doesn't take into account. When you're ranking companies based on these metrics, that's fine. When you're ranking equipment based on output and breakdowns and things like that, that's great. Something else I thought of was sort of online. If you had a retail fashion store, you could start ranking items on there based on how often they purchased, but also how often are they returned. What is the cost of the delivery, things like that, things that we don't often track. What's the customer rating of that piece of fashion item? So rankings are great for me, and I think by taking all of this into account, it gives you a much better viewpoint of whatever you're measuring. Next, I want to talk about optimization. Essentially, all of AI and machine learning is dedicated to optimization, but specifically I want to talk about it in a retail sense. So if you've got a club card, I hope you don't think that's just because Sainsbury's want to give you 50p off strawberries. It's because they want to constantly be tracking what you're buying, when you're buying it and things like that. But what's the benefit to them? Well, in 1994, I believe they started looking at market basket analysis. So starting looking at the association rules. So if you buy bananas, how much more likely are you to buy bread or canned dog food or nappies? What are the association rules? So we can start using machine learning to automate that and finding those rules. So what you can then do, like Tesco do, whenever they move the store around, it's not normally because they just want that to be over there. It's normally that they've found patterns within the transaction data that suggests that if they move that over there, because majority of customers buy dog food and beer or nappies or whatever it is, by moving them together, you'll increase your revenue and maximize sales. In physical stores, it's a lot harder because you actually have physical space that you have to navigate, you have to lift everything up and move it. I was thinking about recently, like, okay, maybe they buy apples and bread, but I can't move my bakery to the front of the store to be near the apples. And should I really be moving veg back to the back of the store? But in an online retail space, it's a lot easier. You can decide how these different sort of products are listed on your website. And you've probably seen when you go on Amazon. If you log into Amazon it's the same website, but ranked differently based on products, based on your transaction data. But not just stuff you're interested in, but stuff you're more likely to buy. So this next slide is a little bit complicated, but I will explain it. So what we can do is we can use what we call an a priori algorithm to start finding patterns within transaction data. So here you can see these are the top 5 association rules between 50 different items on a fashion retail website. So we work with Lone Hood at the minute who are in York, and we want to optimize, okay, well, when somebody logs into the app based on their previous transaction history or based what's in their basket or on their wish list or what they've looked at using cookies data, what should we be suggesting them to buy next? When it says you may also like at the bottom, how can we optimize that so that we're not pairing orange hoodies with purple trousers or green shoes? We're finding these association rules and then changing dynamically the website to maximize sales. So what you can see here is antecedents, which is a very hard word to say, is basically item 42 and item 25. If they're in the basket or they've been purchased, they are, for this association rule, there's a lot more data that goes along with it, but I've restricted it down. For item 2, they are 6.8 times more likely to buy item 2 if they have those in the basket or have bought them previously. So what you can then do now is then you can start ranking item 2 higher up the website instead of it normally being below or just being ranked by, oh, it's a hat, so we'll shove it in hats, or it's trousers, we'll shove it in trousers. We can now say, right, well, they bought a white t-shirt, they bought blue jeans, they're probably going to want some white Converse trainers. Well, let's put white Converse trainers on the same page, or when it goes to basket, say, you might also like this, or offer promotions and things like that. So then you're incentivizing them to do something that they're already 6.8 times more likely to do, instead of saying, well, what about black belt? Well, I don't want a black belt. It doesn't go with my outfit. I've already got 3 of them. You know, I'm not more likely to buy a black belt. And it gave me, I think, over 100 different association rules. It gives you lots of different metrics and confidence levels so that you feel confident that, okay, it's fairly comfortable based on all this transaction history that this is the relationship. So what you could do is if it does give you 1,000 plus association rules, it's going to be pretty hard for you to implement them. So you could filter them out and say, well, I only want to implement the ones that are over 80% confident level. So when you start doing that, then you can start talking to your web designers and your website developers to say, I want to be tracking cookies data, I want to be tracking transaction history data, I want to use this algorithm, I want to create the rules, and I want you to dynamically change the website based on an individual's history. How do you do that? Encourage them to get logins and accounts. You know, whenever you need for some reason you need an account for Zara, I don't know why, but it's for this. It's so that they can track it, so they can relate it back to me as an individual, and they can optimize it based on what I like to see and what I like to buy. Again, if you can't do that, cookies data as well is great for tracking and then optimizing websites. So not too much more of that. So moving on, something that I'm really, really interested that goes back to, again, my pre-data stream days was the idea of predictive maintenance. So if you have a warehouse that looks like that and you've got hundreds of different pieces of machinery, you don't want any of them to go down, because if one of them goes down, then it creates backlog. You've got to, downtime increases, the cost of that downtime, things like that's a significant cost to bear. If, for example, this machine goes down and now you need a specific part, well, that comes from China, it's a 3-month delivery, they're out of stock, they then need to fly someone over to then install it. All that time and all that money is wasted because you weren't proactively predicting when these machines were going to go down. So I don't have any data for this, but essentially what you could do is if you started tracking, electrical output, is there certain weird spikes that the machine's doing that it doesn't normally do? So you're looking for patterns. So you're trying to find patterns in the data that would indicate that this particular machine here is going to fail. And how you do that is if you had all the historical data and said, well, when we see these patterns, it normally means that within 3-4 weeks it's going to go down. You can also track operations data, so how much has actually gone through it. So back in my printer days, we were looking at, well, colour prints damage printers quicker than black and white prints. So if a customer only prints black and white, well, then that predictive maintenance is going to change than if they were always producing colour. Essentially the same with this. So you can track the operations data, but again, you can track it with other things. My favourite application of this was from NASA. So they were tracking audio, and a lot of people forget that audio is a data type as well. So they were looking at audio files because they couldn't actually physically see all the different pieces of equipment that were on the International Space Station. But what they could do was they could hear. So they were tracking all the audio files and then looking for patterns within the audio files that would indicate that a piece of machinery would fail. And if you're on the International Space Station, you want to be quite proactive in anticipating that instead of reacting to it when you're, I don't know, I'm sure Space Hub Yorkshire could explain a little bit better, but yeah, you want to be proactive in that and then getting the parts to the space station. But essentially it's the same for big distribution centres, warehouses and manufacturing units the same. So by doing all of that, you can look for the patterns within the data. Okay, so next one is optimization 2. I didn't really know what else to call it, admittedly. So I'm calling it optimization 2, and it's a project that we've been working on with Bunch Tech upstairs and Dan, who's at the back from Causa, in terms of trying to optimize HVAC systems or heating, ventilation and air conditioning units. So I'm sure you've probably seen these, a lot. I don't think we have any in here to see, but in large retail units, manufacturing units, they have an awful amount of air conditioning units, boilers, ventilation, things like that. But it seems to be a very manual process, or I'm told it's a very manual process of we just set it to this and it just does its thing. Well, how can we use machine learning to start optimizing the air conditioning units and the boilers and the ventilation to reduce consumption, reduce impact on the environment, but also maintain a constant internal temperature? So what we did was we used a couple of models, and I would point out here that AI isn't just a one thing off the shelf that you can just go and like a widget and buy it and just install it straight away. There's many different models, there's many different iterations of these types of models. So for this problem we used two. We used Dan's causal models and we used our own sort of standard models, which you pretty much are accessible to everyone on the market at the minute and that most people are talking about. So we had a target temperature of 18 degrees. That was the internal temperature that we wanted to target. So what we used was a causal model and a standard model to try and predict the HVAC setting that we needed to set the air conditioning units at to achieve what we were trying to achieve. Over a year, causal achieved just under 18 degrees, an average temperature of 17.98, while standard was 18.94, and the deviation is very small. And then because of those sort of optimizing the air conditioning units, it actually equated over a year to quite a significant saving. So with a standard model, it was still good. It's less than a degree out over a year, but excessive wastage was 25,538. We also, I should point out, we don't have a baseline, so we don't currently yet have something to compare it to in terms of what no AI would look like. But essentially, if using AI to optimize it and that was your wastage, I can't imagine what no AI and just sort of setting it at a random HVAC setting would be. So by using causal, they were significantly better at the task and they only wasted £378 over the entire year. So if you're trying to achieve 18 degrees using causal AI to optimize that over a year, 0.02 of a degree out is what we would consider pretty significant. And these savings, by the way, I should say, is based on 185 square meters. So as your unit gets bigger, if you've got like a B&Q store, if you've got a Currys, if you've got a huge manufacturing unit, those savings are only going to go up because you're going to have more units, a bigger space to chill. So this is quite a messy slide, but it basically shows you the difference between causal, which was this model, which hovers around the 18 degree sort of target, whereas standard AI was kind of all over the place. It kind of ranged from just over 20 degrees and all the way down to just under 17. But again, if we had something to show you what no AI would look like, it would be significantly worse. So this is how we're using AI to optimize air conditioning units, boilers, ventilation. I was speaking to someone yesterday about it in terms of applying this to boilers as well in homes, so using IoT devices to say, well, how can we optimize boiler usage, to reduce energy consumption, minimize environmental impact and things like that. Very interesting. We can look at, like I say, with this, we looked at like occupancy, outdoor weather. These are all the kind of inputs that I've spoken about before to try and predict those HVAC settings. So this brings me on to this very empty room, what we represents a data clean room. And a data clean room is a very, very new concept. Essentially, I discovered it when I was over in Toronto at a data conference, and they were talking a lot about it in terms of having a data middle manager almost. So if we go back to the energy use case, if I worked with a bid upstairs and they said, right, for every high street shop, we want to optimize their air conditioning units, can you build a model? And I go, yeah, of course. Well, without a data clean room, I would go into each shop on the high street and I would say, right, give me all your energy data, and we'll optimize it and we'll deploy it, and we'll do that 100 different times. Well, that's great, but if you take advantage of what we call a data clean room, data stream can then act as that clean room. So I can take all the energy data from all 100 stores on the high street, bring all that in, and then use that data to then train the models. So then you get a much more accurate and prediction, and sort of much more accurate model. So if I went into the restaurant on the corner and said, can I have the last 100,000 lines of your energy data? Absolutely, here you go. And I could use that as the inputs, train the model. Great. It's X effective. But if I was to do that for all 100 stores on the high street, now I have 10 million rows of inputs. And you can only imagine how much better the models become training it on 10 million than 100,000 rows. So by using all of that, by having a data clean room, it's sort of a data partner where you can pool your data together to optimize these AI and machine learning algorithms. I've heard other use cases. So if I wanted to understand your TV watching habits, maybe I work at the BBC iPlayer and I want to start optimizing iPlayer to suggest shows that I think you like. Well, at the BBC, I only have data relating to what you've watched on iPlayer. I don't have anything to know, I don't know anything that you've watched on Netflix or Amazon Prime or any of the other TV channels. So by pooling all of our data together, BBC, ITV, Amazon, Disney, Netflix, we pulled it all into a data clean room. We can then train our models on the entire data set instead of a segment of it. So I'd be very good at predicting what you're most likely going to want to watch on BBC iPlayer, but it doesn't take into account what you're also watching on Netflix, Amazon, and so on and so forth. So for me, that's a very interesting use case as well, is sort of introducing these data clean rooms where it's partnering with your fiercest competitors, but with a middleman to say, right, we're going to securely house our data, train the models on it, and then we'll both benefit from the outcomes of it, instead of trying to train your model on just a segment of the population. So I just wanted to bring that up because I think it's really interesting. It's a new way of thinking. I was in Harrogate talking about it, and it was a very stern no from a few people when I started talking about sharing data. But it's not giving data to your fiercest competitors. It's giving data to us. We train the models on all of the population data, and then we roll those models back out to you, and then you all benefit from a greater model. So anyway, moving on. So application 6. So all that you've heard before to now is machine learning. Using inputs to predict an output is essentially the idea, without us having to distinctly tell it how to achieve that. So with software engineering, you say if X happens, do Y. If X1 happens, do Y1. With machine learning, you don't have to specify all those rules and laws. It works out for itself. So that was applications 1 to 5. Application 6 is Gen AI or generative AI, which you've probably all used, ChatGPT, large language models, Gemini, Google Search, Microsoft Copilot, things like that. I have a love-hate relationship with Gen AI, or I have done for the last year, which is that everyone's talking about it and it's always, oh, I wrote my wife a poem using ChatGPT, and I'm like, great, and she loved it, fantastic. But what's the business impact? How is ChatGPT actually going to change anything for me and my business? So I started giving it a bit more thought, and I'm hoping to share a bit more insight on how to start using generative AI models like large language models to improve business and have tangible business impact instead of just writing a poem to your wife. So this will make sense in a minute. I've got two different use cases. One is a customer service bot. So a customer service bot is what I spoke about before. You raise a ticket, you've got a question, you want an answer. Well, okay, great. Well, you can give it the question and it translates that and it goes and finds the answer. Historically, we do that with humans, and someone sat there on the other end, and they've got to go through all the different documentation and find out the answer and then write a reply and so on and so forth. ChatGPT is speeding that up a little bit in terms of it can not only find the answer, but it can write the response. So before today, what I did was I went back to my printing days. I took loads of different manuals, user manuals from printing companies. So I think some of them were 1,004 pages long. That's an awful lot of reading for one printer, for one customer service agent to go through. And there's dozens of printers, dozens of manufacturers. And if you think of how they update them every year there's going to be a new manual. So we're talking an infinite number of pages that a person has to go through and sift through to find certain answers. With data technologies and AI, that's no longer really an issue because text data is now great for large language models. So you've probably seen stuff like this before, but essentially if I was, imagine a receptionist in a dental practice, and I've got a printer on the side, and right, it's telling me I need to replace a cartridge for an E200 printer. Well, I can ask that question. Well, I haven't even specified that it's actually a Canon printer. It just knows that it's a Canon printer. So it goes and finds the answer, but it doesn't just find the answer, it then writes it up in a very step-by-step process for me to follow, like this. So it says, my customer service bot says, to replace a cartridge in your E200 printer, follow these steps. And it gives me 9 very clear, easy to follow steps for me to make that change. So if you think about a self-service customer portal, instead of having customer service agents where they raise a ticket and someone's got to get back to them, or they've got to ring them back, or they even ring the phones, no one wants to answer the phones anymore, you've only got 5 agents and you've got 10 calls. By introducing this, you can kind of hopefully filter out a lot of the requests similar to chatbots, but it's a bit more intuitive, and you can also train its data set. So a lot of people chat GPT, it's a pre-trained data set. With these new GPTs, you can provide your own custom data set. So if you're in, I believe, Karen, wherever are you talking about accountancy data and manuals like that and training materials, I think we were discussing, and saying, I want, my students to, if they've got a question, they could ask a bot instead of asking me, just in case I'm not available or if I'm with another student, they can still get their answers. What I like about this is it not only tells me exactly how to achieve it, but it also gives me some notes, which I quite liked. So for me, the key one in the notes is if you remove a fine cartridge, replace it immediately. Do not leave the printer with the fine cartridge removed. So I might have, as a person, told someone this is how you do it, but I might not have added that in. And you can sort of add that to say, please include these kind of additional notes. Because I might have gone, okay, great, opened it all up, done steps 1 to 4. Now I'll go find the fan cartridge. Well, according to these notes, you shouldn't be doing that at all. So that was really interesting and things. So then I started thinking, well, as a user, I might be like, well, it says here, if you remove a fan cartridge, I'm a receptionist at a dental clinic. What is a fan cartridge? So I've asked it. Now, these kind of questions traditionally go unanswered in customer service because I've told you how to do it, just go do it. Stop asking me questions about what is fine cartridge and why is that important and things like that. But by introducing LLMs and things, it can start saying, right, well, the fine cartridge is a type of ink cartridge, and it gives you that sort of context. So not only tells you how to do it, but if you have questions about the context and the environment and other things relating to it, you can ask it that as well, and it can use the internet to find answers or, again, your own knowledge base. So I thought that was really interesting. So the next thing that I wanted to speak about, which for me is the biggest win with Gen AI, which is turning your business users into what we call citizen data analysts. So a lot of you might have thought, maybe we need to start hiring a data analyst. We're fine, we've agreed a budget, £30,000-40,000. We've gone to market, we've got a data analyst, and they've started. And I've heard countless stories of people saying, yeah, we had a data analyst start on Monday, and so far they've just told us nothing, just told us everything we don't want to know. They've told us everything that they find important, but it's not business critical. It's got no business relevance. Yeah, it's great. They've done some good analysis and machine learning, and they've predicted X, but we don't care about that. So they don't really have that domain industry knowledge that you probably need in a good data analyst. But who does? Your existing business users. So if you go into your finance departments, you go into sales departments, no one knows that department of that business better than your existing business users. And you're never going to find that with a data analyst. Data analyst career paths are usually they study maths, physics, chemistry. They go on, they might do computer science at university, then they fall in love with data, and they go on to become data scientists and engineers. They've never had that sort of commercial awareness or training. So by implementing generative AI technologies, you can now combine the two. You can now empower traditional business users with Gen AI technology so they can start asking business questions and converting that into various data analysis techniques and ultimately potentially machine learning without the initial training cost of having to put them through a 6-month data analytics training program. So that's all well and good, but what does it look like? So imagine you do go to one of these business users and you've identified them because they're quite proactive, they want to get involved with new things, and they always have business questions. And for me, whenever I see data questions, they're always trying to get them answered by IT because IT have access to the raw data. But IT aren't really data literate, they don't want to give you answers or do analytics. If the server's up, they're happy. So normally they go unanswered. So by using generative AI, anyone in your company can start asking questions like this. So I want to know how many unique customers have visited my online store in the last 30 days who have made a purchase. So if you think about your business data in your own businesses and where that would be located and where you would have to go to find it. Well, if you had a generative AI model that operated amongst that and it had access to finance data and sales data and so on and so forth, it could run a very simple SQL query like that to go and find it. So for everyone in the room, you might be thinking, oh, not code, we don't really want to be looking at that. But this is what we call SQL, which is a database querying language, and that's how we would write it as data analysts or data scientists, data engineers. We would be writing SQL queries. Now, to try and get a traditional business user to learn SQL, quite significantly challenging, especially across the organization. But if you can ask a question like that, a typical business question, and it can create it for you, you can then go and execute that and get the answers yourself instead of asking IT or asking your manager or ultimately just never having the answer to your question. So these are the main benefits I think Gen AI offers, not so much the poem writing. So another one that I want to show you is, please can you select customer account IDs and names from the sales data that are serviced by me, Elliot Fearn, and join them with finance data, including payment terms and days, and list them in descending order from highest payment terms and days from highest to lowest. So essentially what we're doing is we're trying to do something that a lot of business users struggle with, which is merging data. A lot of people download a report from sales, download a report from finance, and try and find a way to mangle it together to eventually do this, and then they're going to filter them and so on and so forth. But by getting AI to do it, you can then turn it into the SQL query, which is what we would write if we were doing it, and then you can go and execute that. So essentially what it's doing is exactly what you asked. It says select customer account ID, customer name and payment terms from this location, and join it with finance data on this common column. So you'll have two columns in each data set that you can combine the two on. Join it on that, but I only want the data returned when it's serviced by me. So if I'm an account manager and I want to start looking at these things, I don't really care about Jack and Jill's data, I only want mine. And then also order it by payment terms and days. So maybe I want to start looking at which of my accounts have the greatest payment terms, but I don't have access to that because it's in the financial data and things like that. I also don't know how to write a SQL query because I'm just a general business user. I've never had any of this kind of training. And as a business manager, managing director, you're thinking, well, God, trying to train every user to become a data analyst and start writing in SQL and Python is going to be significantly challenging. So with Gen AI, you can just turn that into that to get your answer. And then you might be thinking, well, I also don't want it in a table. So then you can say, can you create a line graph that tracks sales data over the past 6 months, but filters out all sales data that isn't serviced by me, and it remembers who I am, so I don't have to tell it again what my name is. And yeah, of course, it can create the graph. Now, for me, this is a very ugly graph, and you can tweak things like this, and you can also tell it, drop the grid lines, remove this, I don't want the titles, like you can do in Excel, but you don't need to know where in Python or SQL code you would change those settings. You can just ask generative AI to make the changes for you. So you can start thinking like a data analyst, start thinking like a data scientist, and start asking business questions to Gen AI to return the results without you needing all the training. And me being me, I worked on the formatting. I just said, make it look like an article in The Economist. So it kind of changed the formatting a little bit to match an economist's kind of to graph as well. So if we move on slightly, so I'll just have to go back. So I've got a video now. So essentially at data stream, what we do, is that on? Sorry. So what we do is this is our sort of solution. So when you come to data stream, first thing we do is we connect to all your different systems and we automate the extraction layer of your data. So we bring in all the data we possibly can from wherever finance, sales, operations, customer service sits. So we start bringing all that in. And again, do you want to put all that data in ChatGPT? Probably not. So if we're bringing it all into here, can we include generative AI into our data pipelining solutions? Of course we can. So we have a little section on our solution which allows for everything I've just spoken about. So it says here, this is the business question. So I want you to generate a list of the top 10 products by total sales amount that also includes the number of transactions and the average transaction amount for each of these products. Additionally, for each product, calculate the percentage contribution of its sales to the total sales of all products within the same revenue category. The list should only include products that have been sold at least once and should be ordered by the total sales amount from highest to lowest. So you can imagine that for a regular business user is a very difficult task. It requires you to go into data sets in many different systems, start exporting reports, trying to join all that data together, and then start filtering out things you don't want and ranking things and drawing graphs. Particularly cumbersome and difficult for most. So if I just play, will it start? No. So if I just play that there, you can see it's asked the question and now it's written in a SQL statement. So this one's a lot more extensive. I think it's 50 lines of SQL code, but it's doing everything you've just asked it. So instead of trying to teach someone to do this, it writes it for you. So what it's also doing now, it's not only written it for you, it's creating an AI explanation which says, you've asked me to do this, this is what I've written, and these are the steps in the SQL query that you might not be able to understand because you're a business user, you're not an SQL analyst or anything like that. But these are the bullet points of essentially what we're doing. We're taking this from here, we're doing this calculation, and this is the result we're getting. What you can then do is you can then either execute that SQL code, so then you'll get the result you want. So it'll print it out as a CSV file that you can open up in Excel, or you can push it to a Power BI dashboard to visualize it. What you can also do within our solution is save it to a transformation. So a transformation is, I've got data, I want to do something with it. So a transformation is you can save this and you can run it multiple times. So if that question comes up weekly, maybe if it's in a board meeting, you do a month, or a town hall meeting or anything like that, and you want answers to that question regularly, you can save the transformation so you don't have to keep asking it every month. So then from now on, we can start building these transformations in the pipelines, so then you can keep asking better and better questions, but also saving the results and saving the SQL queries. So for me, generative AI, this is where the biggest wins are, which is turning your traditional business users into data analysts, data scientists, data engineers without needing the excessive training. And as they start having this kind of technology, they'll probably be naturally curious and start saying, well, I asked it to do this. Well, okay, it's got to select this. Okay, well, where's that coming from? Okay, it's coming from product sales. So you start to pick things up, and you'll start to be able to see how things are going wrong. So you're not actively telling them to learn SQL, but by doing this and asking the business questions, they'll start picking it up, as well as having the AI explanation down the side. And if they wanted to then start playing around with it and start saying, well, how would you do it if I wanted to change this? And you can start comparing. The other thing you can do in here is you can compare two scripts. So if you said, okay, well, this is what we were originally measuring gross profit as, this is what we're now going to measure it as, explain to me the differences. So why have you not taken depreciation or different financial terms into account in this one compared to this one? And we can also provide lots of documentation in here to document all that journey as well. But that's going on a bit about more data stream things. So I wanted to address this quickly. We've only got about 8 minutes left. So I know you've all come for AI in action, and I'm sure maybe a lot of you were thinking, well, we wanted to see real world examples. All the data so far has been simulated. It's been, designed for what I've been trying to show you. Where are the real world examples? And the issue is we've been going for just under a year now, and no one that we come across is ready for AI. Everyone's talking about it. Everybody wants to get into their business. But as soon as you say, great, well, what do you want to do? Well, we have this question that we want to figure out. We want to predict this. We want to optimize journey planning or route optimization or the warehouse, whatever it is, and we want to use AI to do it. And I say, well, where's your data stored? And it's exactly the same as the company I was at before. They've got a different system for every different area of the business. They might have multiple. At my old employer, we had 4 CRMs across the business. We had 2 ERPs. We had third-party applications for from the manufacturers. We had data stored in Trello, Google Sheets, Excel, SharePoint, PDFs, emails. All this data is trapped in what we call data silos, which isn't really great for what we've just been going through. So if we look, and I know this was about 45 minutes ago, but if we go back to our application 2, yes, I stood up here and I explained the importance of all these factors in predicting, in ranking customers in terms of profitability score. That's great, but if we actually start to break down the data and where you would have to go to start getting it into this format, you'll see how tiresome and cumbersome it would be. So sales volume, okay, normally an Excel spreadsheet managed by sales, or Pipedrive, CRMs, HubSpot, things like that. Support tickets, well, that's back downstairs. That's in something called Zoho, a CRM, or Zendesk support. I then have to export all of that into a certain place. Average resolution time, these calculated fields, I might need to start taking data from different areas of the business to make this calculation. Support consumables, again, in what we call Advantage, a different CRM for managing things like that. Cost of sales calls, well, now I need to go and figure out what the cost is of one of our sales guys going up there. So, okay, well, I need to see, well, what car did they go in? Was it electric? How much petrol did they spend? What was the expenses for it? Did they take them out for a meal? How much do we pay the account manager so I know how much time he was spent there and we can equate that to an actual pounds value? That's maybe 5 or 6 different systems I've had to go to there for one column, and we've got 9. So then we've got missed payments, and I've got to go back to Sage 50 and start exporting reports. And then joining all this data is usually quite tricky because it's never been designed. None of the processes in the business have been designed for AI or machine learning or any of this advanced data. It's really difficult. So finance might have a different customer ID for you than sales does. So if I'm saying, well, bring in ABC Limited sales data and their finance data, well, in sales, their reference number is 0001, but in finance, it's QRT0x3, and you're like, well, now I need to map the two to try and join that data. So as simple as I made it look for the last 45 minutes, there is an awful lot of work that goes into it, and that is why ultimately there are no real-world examples yet, because we are spending so much time trying to get all this data together so that we can ultimately implement all the solutions we've spoken about today. So I wanted to briefly touch on, we've got 4 minutes, why data stream, why we set up what we had data consultancy, and it's essentially what we've just been going through, is that I was tired of going to customers and seeing their data being all over the place, even just for business intelligence, so Power BI, data visualization tools. A lot of things that people were talking about, you know, a couple of years ago, now it's AI, machine learning, but the same problems were then as they are now, which was I'd go in with a BI solution and say, we want to measure this, we want to measure that. I said, well, where's your data exist? And it's messy, it's not been transformed. And that's because it doesn't follow sort of what we call data streaming or data pipelining. So what we suggest is, first step, we've got to extract the data. So we've got to connect to your existing tools, all those CRM systems, all those ERPs, them Excel sheets that we all know we've got. We connect to them. We're not trying to convert you to something new. We don't want to say, you know, all your problems would be solved if you went to Dynamics 365. It's just not true. You'd have the same problems you had with HubSpot and Zendesk, just migrated over to Microsoft. But what we add, which a lot of other competitors don't add, is this transformation layer. So a lot of people focus on the capture, and they sell a software, you know, SaaS product, HubSpot and different CRMs, and they say, hey, if you move to us, you'll have everything you need. It's just not true. Where the real tangible benefit is in what we call the transformation layer. So this was extraction layer, and that was load. This entire gap here would be a transformation layer. And what happens in there is this. You're taking your data, you're cleaning it up, you're reformatting it, you're encoding it potentially, you're joining it with other data from other systems that we've captured for a specific purpose. So we might have a business question that we want to answer, or we look at where that data is, but then we do need to clean it up. I've worked with customers and they always tell me our data is fantastic, and it never is. And they go, our customer service people always fill in this column. They don't. Unless they have to, they won't. You know, if they can get away with it and no one's tracking it, no one's monitoring it, you're going to have issues. It's not going to be accurate. It's not going to be as varied as you would expect. And then we always store it. So we always like to store it in cloud SQL databases. So we optimize how the data is stored for our specific purpose. So a lot of people are still working on on-premise databases and things like that, but they were just sort of set up as a data dump because they never really had any intentions to use it for any specific purpose. And as long as we were storing it, that was good enough. Well, for us, we optimize the way we're storing it. And the best way I can explain that is our first ever customer, and their data was huge. And they had loads of different product information. They had ingredients, they had emissions, they had packaging information, they had what countries it was going to be registered in. And when you added all that up and all the different iterations of each row, I think it was about 10,000 lines per product. But by splitting that and using data technologies, we could split it between 7 different tables. And by splitting it between 7 different tables in the database, we then drastically reduced the storage, which meant it was a lot easier to understand, but ultimately a lot easier to analyze, because if we didn't care about country information or we didn't care about ingredients, we wouldn't bring it in. We would just bring in the tables and columns that we needed. And then the analysis is what we've been speaking about all day. So the analysis is the machine learning. It's the cognitive analytics. It's the prescriptive, the diagnostic, not just simple descriptive. What did we sell last week? What was that compared to the year before? Great, important. We're great at doing stuff like that. But where the real value is these new different types of analytical skills. And ultimately then, once we've done the transformation layer, we can load it into your end system. So whether that's a PDF report, normally an Excel file, we like to do Power BI dashboards because people seem to really like them. So we can then start presenting that data, because nobody wants to read a machine learning document that looks like it was written by an academic. They just want the answers to their questions. So they don't care about Z values or evaluation metrics. They just want what is the output, and present that in a way that it's non-negotiable. That is the answer. So that's why I think by doing it with the extraction and ultimately the loading, the biggest benefit you've got is in that generative stuff, in sort of that transformation layer. The generative stuff, again, coming in here, where you've got clean data sets that you can use Gen AI, ChatGPT, things to start asking business questions, because it's got somewhere to look. If it's got 1,000 different places to look and the data's messy, it's going to start projecting errors forward. And the best story I ever had was when I was doing my master's. As part of my dissertation, my previous employer hired us to work with their sister company, because they were operating separately and they had separate sales functions, but they were working in terms of their customer base would buy stuff from one and stuff from the other, but because their sales function was different, they never collaborated. So what they wanted to do was use machine learning to find patterns within their data and try and help join the sales forces a little bit by saying, okay, well, if we get a new customer based on historical data, we think they're more likely to buy this from company X or this from company Y, and then we can optimize the entire customer journey and the sales journey as well. But the issue is I had to postpone my dissertation 4 weeks because it took 10 weeks for them to get anything to me. And that's ultimately my main message, is that data isn't ready for machine learning yet, and we need to do all these steps to ultimately get it ready, because otherwise it's going to take you 10 weeks. And the other thing that I would also add before we finish is the need to automate it. Last week we heard at the Guildhall that 85% of AI projects fail, and that's because they don't automate it, in my opinion, because you'll hire machine learning people, we'll come in, we'll take whatever data we can kind of get our hands on, and we'll give you an answer to your question, and then we'll leave. Well, if you haven't automated it, that's an awful lot of data capture, data cleaning and storage, and all the analysis that it just exists as a file on somebody's computer and is never rolled out to production. So by using what we call data streams, by automating the capture, automating the cleaning, automating the storage, automating that deeper analysis, and automating presenting that on a dashboard, you can build upon your analysis and you can build upon these data streams. So you don't have to keep doing it in what we call batch processes. You can do it one time and it works really well, automate it, and then you can do another research project. You can look into a different sort of business area and automate that. And by automating all these data streams within your business, that's how you're going to maximize your return on investment, and that's how you're going to make sure that any machine learning project moving forward is going to be a success. And that's it. So thank you all for listening. I think there's some food at some point in the back if you're all a little bit hungry. So yeah, thank you for coming.